Hello viewers, you are welcome to another episode of Staad Pro. In this episode, I'll be showing you how we can design a steel structure in Staad Pro V8i. So let's get into it as soon as possible. I can go to new project, then you go to space, then let me give it a name. Let me just call it steel frame, and then I'll pick meter as the default unit for the length and then kilonewton for the force. Click on next. Then I can run my structure wizard, so you can just open the structure wizard and then you click on finish. Alright, so it will directly take me to structure wizard. Then I can pick frame model, then just double click on the bay frame here. Then the length, I will use a length of 8 meters, and then height, I will use height of 6 meters, and then the width, I'll use a width of 5 meters. Okay, then I'll make everything to be two bays. Okay, so I can have 2 bays each. So using 2 bays each, this will split them into equal distance. For example, if you click on this, you see 4 meter. All right, but if you don't want it to be 4 meter, you know what to do, just change this. All right, but I want it to be equal distance, so just click on apply, and then I can transfer the model by clicking this, then click on OK. You can drop it at the origin, so click on OK. Alright, so here is the structure. The next thing to do will be to assign the property to the section. So I can go to general, and then under the property you go to section database. Alright, British is what I will use. You have other steel sections. Obviously you can see you have steel, you have cold formed, you have timber, and you have aluminium, but for today it is steel design. Alright, so and then I want to use British. So you have the universal beam, universal column, you have the pipe, universal pipe, you have the joist, you have the channel, you have the angle, you have the tube, and you have the pipe. So I'll be using universal beam for now, and then I will pick a section of 254 by 22, which is 254 by 102 by 22. Then you can see some other options. This is if you want to use single. ST is if you want to use a single section, and that is what I want to use. We have T, this is when you want to use a T section. Obviously there's no T section here, so this is what you use for T section. If you want a double profile, this will give you a universal beam, but instead of one it will give you 2. Alright, then the 2, maybe you have to weld the 2 together, so there will be a little bit spacing between the 2, so you can insert the spacing here. This is when you want to use a composite section, that is you have a steel, then at the top of it there will be a concrete, so you can put the thickness of the concrete, the grade of the concrete, and the width of the concrete, also the density of the concrete. Then another one is TC. This is when you want to have a plate, a steel plate at the top of your beam. This is another one when you want to have it at the bottom of your beam, and then this is where you want to have it at the top and the bottom of your beam. But I'll pick the ST, which is basically just the universal beam, and it is only one, which is single. So you click on add. Then for I also need one more, which is for the universal column. That will be for the column, so I'll use 203 here. Let me use 203 by 203 by 46. Then you click on add. So that should be enough, right? So you can close that. This is for the universal beam, I can assign it to all of the beam. This is for the universal column, I can assign it to all of the column. So let me select every beam in the Y direction, so that will be my column. Then I can assign the universal column. So you just click on assign to selected beam, then click on assign. Yes, so all the universal column have been assigned to this. Then I can just go to select, and then go to missing attributes, missing property, then it will select the remaining that have not been assigned. Then that way I can assign the universal beam. So I have everything assigned now. The next thing will be to assign the support. So you go to support, then I can create a support. I will use a fixed support for everything, so click on fixed support. Then let me put this in front view. Then I select all of this, click on the supports, select all of them. Then you can assign to selected node. So selected node, I can put it back in isometric view. So now I have all the support and I have the property. The next will be to define the load. So go to load and definition. I can go to load cases detail. I had one. Then the first one, let me call it dead load. Alright, so this should be dead. What I just do here is I'll add the self weight and then click on add. Let me have another one. Let me call it live load. Okay, then I'll call this live. Alright, and then you can add that. So let me close. Under the dead load, let me just add the self weight. The self weight is here already. You can just click on add, and then that will be there already. So click on it, then you can assign to view. So assign that to view. So everything has been assigned. Then I can go to live load. I'll just add the floor load for this one. So click on add. Then I can go to floor load. So let me add about maybe 3. So that's -3 in the global Y. The minimum, that should be 0 meter, and that's the minimum. Then maximum, that should be the maximum height of the building. The maximum height of the building, the whole building is 6 meter tall. So let me put 6 meter here. Then you can click on add, then you can close that. So if you click on this right now, you will see how the load has been distributed. You see, like, you have a floor load, then you can see you have a rectangular load distributed to this beam. You have a trapezoidal load distributed to these long beams. So that is how a floor load is applied. So now that I have everything, I just need to go ahead with the analysis. So go to analysis and print. Then let me just use no print. Click on add. Let's close that. We can check the 3D rendered view. Let's see how it looks like. So this is the 3D rendered view. Let's try to zoom in. You can see how the section, you can see the kind of interlock, you see how the wedding. So let's close that, and then we can just go ahead and do the analysis. So go to analyze, run analysis, click on save. Alright, so the analysis has been done. You have 0 warning, 0 whatever. So if you're interested in seeing the analysis results, you can just go to post processing, and then you can click on OK, and then you check whatever you want to check, be it your shear force, your moment, whatever. So that will not be the problem now. So let's go back to modeling so that we can do the design. So you go to modeling, and now from there you can go to design. Here you can see what you have here. You have design. We just want to design the steel now. We are done with the analysis. Then you can go to design. Then by default, the first one is steel. You can see another one is concrete, another one is timber. You have aluminium, and then you have the shear wall. So you pick the steel. The default code is BS5400, so that's not a problem. Make sure that is there. If you want to use maybe 5950, you can go and pick 5950. Okay, but BS540, it has about 10 parts. So some part of it, you can use it for structural steel work, whereas 5950 basically is for structural steel work. So you can use any of the two. That's not a problem. So it depends on how you can use it, right? Then you go to select parameters, so that I can select the needed parameters. Go to select parameter. Everything will be selected automatically. Then I can just take everything back. So I will pick the one I need. First of all, I need E stiffness. That's a compression member. You can take that. KY value, you can take that. This, you can take this. This will also be essential. LY, I can take this. This main, that's for the grade of concrete. I don't need any grade of concrete, because if you remember when we were picking the database for the steel, I showed you one where you can use a composite design. That is when you have the concrete and the you have the concrete and you also have the steel. So that kind of design, that's when you need that's when you need the grade of concrete, but I don't need it right now. Here you have the net section factor. I need it. PY, I need this. Take this. Type of section, I can take that. Grade of steel, I don't need to take it. I've taken PY. Track, can take this. Unsupported length of beam, you can take this. Weights, I don't need weights. So just click on OK. Alright, so before we go ahead, I would like to confirm something. Let me confirm the height of the building. I've forgotten. I think the height is 3 meters, but I'm not sure of the width. So this is 3 meters, fine. Then what about the beam? Length of each beam, okay, in this direction is 4 meters. What about this? I have sum of 2.5 meters. Okay, 2.5 meters. So let me just put this at the back of my mind. I have the height to be 3, I have the short beam to be 2.5, and the long beam are 4.0. so that's fine. I can take away that back. Then you can now define your parameter. After you've selected the parameter, you have to define the parameters. So go to define parameter. The first one is the E stiffness. This has to do with column because it is the compression member. So E stiffness, you can see compression member with moment design. So you have two options. You can either pick 0 and you can pick 1. But what is 0? What is 1? 0 says the member passes if either clause 4.8.3.3.1 or clause 4.8.3.3.2 are less than the failure ratio. Okay, so the failure ratio is usually 1. So you also have the other one which says member passes if both clause 4.8.3.3.1 and this other clause are less than the failure ratio. So you can pick any of the two, but let me just brief you what those are. You can go to your, I believe you have your code. This is clause 4.8.3.3, and that has to do with what? Overall buckling check. So that's what I said. Buckling has to do with column. So this is compression member. So the first clause under that is 4.8.3.3.1, and that is what we call the simplified approach. So this is the formula for that, and the failure ratio is 1. So this is if all of these, which is F over AG whatever, is less than or equals to 1. Then you have the other one, which is 0.2. This is moment, and then whatever, that's also equals to or less than 1. Then what we have here in Staad Pro says if either of the two clauses are satisfied, then the member passes. Then the other one says the both of the clauses have to be satisfied for the member to pass. Okay, so each of the two, so you can pick any. I would prefer to pick either, not both. Okay, so you can use the simplified or you use the exact one. So the exact one is 4.8.3.2. so just click on add, and then KY is the stiffness coefficient. By default you put that to be 1, so you can add. You have the KZ, that's also the stiffness coefficient in the Z, so by default put that to be 1. Then the next one, which is LY, that is the length in the local Y axis. Okay, so that has to do with buckling as well. You can see it has to do with slenderness. Let me put it like that, not buckling per se, slenderness. So you can see the default is selected as the length of the column, not beam. You know, it is column actually. So I will put that to be what's the length of the column? The length of the column is 3 meters. Okay, but that is the default. You can actually change it. The formula is right here. You can see KL per R. K, that's your stiffness factor, which you've inserted earlier, which is KY. Okay, and then L, that is the length of your column. Then R, that is the radius of gyration. So if your K is 0.5 and your L is whatever, your radius of gyration is so you just have to insert the value here. So I'll use the default length, which is 3 meters. Also for LZ, I'll use the same thing, that is 3 meters. Then the net section factor, I'll use that to be 1, which is default. I'm sorry, I'm not sure I added this. LZ, add again. Okay, NSF, add. But if there is repetition, I have to delete it. Then PY, that is the grade of the steel. I will use 460. So 460, then 1000 because of the units. You have to be very careful of the units. So the permissible ratio, just put down to be 1. Oh, I'm not sure I added this as well. Ratio, put this to be 1. Then SBLT, which is the section type, that will be root section. The built up section, that is the the code formed. So pick the root. So click on add. Then track, it should print all critical member. If you wanted to suppress the critical member, the stresses, so I'll pick print all. Click on add. Then UNL, that is the unsupported length for the allowable bending stress. So this has to do with beam. For example, the LY, that's slenderness, that has to do with column. But the UNL, this has to do with the beam. Okay, so we can have two. First of all, I will use the default length of the beam. So I have a beam of 2.5 meter, so I will use that one for the 2.5 meter beam. I also have some beam of 4 meter, so I will use 2. Okay, then we can close that. So let me check if there is repetition. E stiffness, KY, KZ, LY, LZ, NS. Oh wow, there is no repetition. I thought as much. Okay, so E stiffness, obviously you know E stiffness has to do with compression member, so that should be added to column alone. Okay, so select all of your column, so that should be beam parallel to Y. Right, then I can now assign this. So click on assign to selected beams, and then you click on assign. So that will be assigned. Then KY, that has to do with beam, the column as well. So select all of your column, beam parallel to Y, select column, add to selected, add. Then KZ as well, it has to do with the column. So go to beam parallel to Y. Then I can also assign that. Yes. Oh, sorry. KY should be for everything, you know, inclusive of the beam too, because you can, there's no other way for you to select the stiffness of for the beam. So let me just use assign to view for KY. So KY assign to view, click on assign. Okay, so that's for KY. Also for KZ, assign to view, so everything we get assigned. Okay, perfect. Then LY, that will be for the column alone. Select Y. Alright, so assign selected beam. Yes. The LZ, that's for the column alone as well. So Y, then assign. Then NSF, that should be for assign to view for both beam and column. Then the grade of steel, that is for everything, assign to view. Right, then the ratio, that is assigned to view. Also the hot root steel, that is for assign view, everything is hot root. Then track, that is for everything, it should print the critical stress for everything. Then UNL, that is just for the 2.5 beams, so you have to pick all the beam parallel to Z direction. So select beam parallel to Z, so those are the 2.5 meter beams, right? Then you can assign to selected beams. Then the next one, which is the for the 4 meter, so you have to select the beam parallel to X direction, which are the 4 meter beams, and then you can assign to selected beams. So that is perfect. So we are done defining the parameter. The next thing will be to define the command, what we want it to do. So go to command. So I want to check the code, that is the design. So just click on add, that is I want to add. Then another thing you can do is you can take member takeoff. So click on add again, then you can close that. So you can do many more, but I just prefer to do just the 2 of that. So check code, you should check code for everything. So assign to view, assign, yes. And then the member takeoff, you should do member takeoff for everything as well. So assign to view, perfect. So we are done doing everything. The next thing will be to analyze. So when you analyze, what you are doing is you want to design, but obviously there's nothing like design here, so we still be using the analyze function. Then you run analysis, yes, save that. Okay, so we have 0 warning, 0 error, and then 1 note. So you can just go to view output file, then click on done. Okay, so you can click on results, then you can see you have your steel design. So click on steel design. So this is your steel design. You can see for the steel UB, which is universal beam 254 by whatever. You can see what you have here. You have pass. So let's maximize that. So you see the calculation, all the section properties and everything. Okay, so this is another one. Okay, another member. You can see this one also passed, so you can check for everything. This is another member, this also passed. So also you can check your steel takeoff. You know, we also picked takeoff, so click on takeoff, then you see the takeoff. So this is the steel beam, the length is 4 meter, the weight is 0.86. you know, so this is everything you need to know concerning the design of steel beam in Staad Pro. But this is one method of designing a steel section in Staad Pro. There is another method of designing steel structure in Staad Pro, and that is what we'll be doing in the next video. So if you like this video, make sure you give the video a like, and if you haven't subscribed, kindly subscribe to my YouTube channel. Thanks for watching.